Chapter 4 review. We're going to review complex numbers in standard form and then in trig form. Number 1, write the complex number in standard form. So to review, standard form is a plus bi, and our problem is 6 plus square root of negative 4. We know to write this as 6 plus 2i. We can do this slowly. Let's do the square root of 4 times square root of negative 1, which is 6 plus 2i. Number 2, square root of negative 48. We can write it as square root of 16, square root of 3, and square root of negative 1. We know square root of negative 1 is I, so this is very important. And also, I squared is negative 1. So let's write this one more time here. So first, I squared is negative 1. That's how we created it, which means I squared of negative 1. So these two are equivalent. Back to our problem, 4 root 3i. It is in a standard form with a, the real part, being 0. Number 3, we're going to perform this operation, 7 plus 5i plus negative 4 plus 2i. At the real parts, 7 minus 4, 3. At the imaginary part, 7i. Number 4, 5i times 13 minus 8i. We multiply 5 times 13, 65i minus 40i squared. Now we know I squared is negative 1, so that's equal to 65i plus 40, and 40 plus 65i. This is the standard form. Number 5, 1 plus 6i, 5 minus 2i. So we multiply complex numbers just like we FOIL. So we have 5 minus 2i plus 30i minus 12i squared equals to 5 plus 28i plus 12, because I squared is negative 1. And finally, 17 plus 28i. Number 6, how do we divide? Negative 10 over 3i. This can be easy because we only have the imaginary part on the bottom. The rule was you multiply by the conjugate of the denominator, which in this case is negative 3i, but just multiplying by I will do the trick. So just either negative 3i or just I. All we need is to create I squared, so negative 10i over 3i squared, which is negative 10i over negative 3. And finally, simplify this, 10 thirds I. Again, we have imaginary part, but not real part. Number 7, how do we divide complex number when we have real and imaginary part in the denominator? So the rule was we multiply by the conjugate of the denominator, which is 4 plus I, and then have to FOIL on the top. So 24 plus 6i plus 4i plus I squared over 16 minus I squared equals, so on the top, like terms, 24 plus 10i minus 1, because I squared is negative 1, on the bottom 16 plus 1. So 23 plus 10i over 17, but that's not in a standard form, so we need to separate the real and the imaginary part. And if there's something to simplify, we should do that. So 23 17ths plus 10 over 17i. Number 8, find all solutions. So the equation is x squared minus 2x plus 10 equals 0. let's recall the quadratic formula for quadratic equation. So it's negative b plus minus square root of b squared minus 4ac over 2a. So this is our formula. Back to our equation. A is 1, b is negative 2, c is 10. So we substitute, and we have negative b, so that would be negative 2 plus minus square root of negative 2 squared minus 4 times 1 times 10 over 2 times 1 equals 2 plus minus square root of. All right, so 4 minus 40 over 2. 2 plus minus square root of negative 36 over 2. We know how to write square root of negative 36. That's going to be 6i over 2. Let's separate it and simplify. 1 plus minus 3i. So we got two complex solutions for this equation. Number 9. I think it says here simplify. So simplify the expression negative 8i to the 6 plus I squared. Now let's talk about the powers of I first. The powers of I. So I to the 1 powers I squared is negative 1 by definition. I to the 3rd is I squared times I, which is negative I to the 4th, we can write as I squared squared, and I squared is negative 1 squared, so that's 1. And then they start repeating. So I to the 5th would be I to the 4th times I. But I to the 4th is 1, so it's I. I to the 6th will be I to the 5th times I. So I times I, which is I squared negative 1. So you see how they start repeating. So we have 4 possibilities for the powers of I. It could be the I, negative 1, negative I, or 1. 4 possibilities. And we can determine that no matter how big the power is. Let's say I to the power 37 by dividing 37 by 4 and seeing what the remainder is. So that is 9, 36, remainder 1. So what that means is I to the 37th power is the same as I to the remainder power, okay, which is just I. So when you divide by 4, you have 4 possibilities. Remainder 0, which is the same as remainder 4, or remainder 3, remainder 2, remainder 1. So back to our problem, I to the 6, we can do it again. I to the 6 is, if you divide 6 by 4, remainder is 2, the same as I squared, which is negative 1. So we can simplify this negative 8 and then negative 1, and I squared is negative 1 as well, so that's equal to 8 minus 1, which is 7. All right, we are number 10 right now. Simplify. Simplify the expression 1 over I to the 7th. All right, so I to the 7th, if you divide 7 by 4, the remainder would be, okay, this is 4, the remainder is 3. So that means I to the 7 is the same as I to the 3rd, which we know is negative I. So we have 1 over negative I. How do we simplify this? All your answer has to be written as standard form, a plus bi, unless otherwise specified. So I'm going to multiply by I, both top and bottom. And I have I over negative I squared, but I squared is negative 1, so negative I squared is 1. So this is just going to be I. So we simplified it. So next problem, 11. Determine the number of solutions. Determine the number of solutions without solving it. So the equation is x to the 5th minus 2x to the fourth plus 3x squared minus 5 equals 0. So we have degree, the degree is 5. We have this theorem that says that if n is the degree of the polynomial, then you have n complex solutions. So we have 5 solutions. Number 12, use discriminant to determine number of solutions and what kind. So a little review here. The discriminant is the part under the square root in the quadratic formula. This is the discriminant when you have quadratic equation. This is only for quadratic equations. So if the discriminant is positive, we have 2 real solutions. If the discriminant is 0, 1 real solution. And if the discriminant is negative, we have 2, I'm going to say here, no real solutions, but 2 complex solutions. So, example for number 12 is 6x squared plus x minus 2 equals 0. A is 6, B is 1, C is negative 2. Discriminant, B squared minus 4AC equals 1 squared minus 4 times 6 times negative 2. All we want to know is positive or negative. Looks like positive. So 2 real solutions. All right, next problem. Number 13. Find all zeros. We know 0 solutions, real solutions, x-intercepts is the same thing. So find all zeros, and the polynomial is 4x to the third minus x squared plus 128x minus 32. We know the degree is 3, so we expect 3 complex solutions. So let's factor by grouping. The first 2 have a common factor, and that's x squared, and inside 4x minus 1. The other 2, these 2, we have common factor 32 inside 4x minus 1. So 4x minus 1 is common. We'll factor it out, and what's left is x squared plus 32. Now, we take each factor and we set it equal to 0. And we solve for x. So here is 1 real solution. The other factor, it's not going to be real. We're going to have x squared equals negative 32. So x is plus minus. When you square root, always have to do plus minus. And 32 is not a perfect squared, but it has a factor that's perfect squared. So that's 16, and then 2 and I. So plus minus 4 root 2i. So we have 2 complex and the conjugate of each other, and 1 real, just like we expected. Number 14, find a polynomial with real coefficients that has the given zeros. That has the given zeros or solutions. So the zeros are 2/3, 4, root 3i, and negative root 3i. So 4 of them. Is there anything that's not given but we can find out? No, because these 2 are conjugate of each other. Sometimes they give you 1 conjugate and you have to figure out the other. So let's write this in a factor form. If 2/3 is a 0, x minus 2/3 is a factor. If 4 is a 0, x minus 4 is a factor. If root 3i is a 0, x minus root 3i is a factor. And finally, the last one. So 4 zeros, 4 factors. After you FOIL, then like terms, you simplify, you should get 3x to the fourth minus 14x to the third plus 17x squared minus 42x plus 24. So it's a good exercise to FOIL and simplify. Number 15, plot and find absolute value of z. So we have 5 plus 3i, so we need to plot it. 5 is the real part, 3 is the imaginary. Right here. Absolute value of z, square root of 5 squared plus 3 squared, 25 plus 9, square root of 34. So that is the absolute value. Number 16, write in trig form. And the number given, z, is in standard form. So it's 5 minus 5i. We need to find the absolute value and the angle, but let's sketch it. So 5 is real, 5 is here, 5i is here, and our number is in the fourth quadrant, and this is the angle theta. So the absolute value of z, which is r, square root of 5 squared plus 5 squared, square root of 50. So we can simplify that as square root of 25 times square root of 2. So 5 root 2 is r. The angle theta, can we figure it out? This here is going to be 45 degrees. So our angle theta will be 360 minus 45, because isosceles triangle, or you can do tangent. So 315, or write it in radians, 7 pi over 4. So finally our angle in the trig form will be 5 root 2 cosine of 7 pi over 4 plus I sine 7 pi over 4. And we leave it like this. So next problem, we'll say perform the operations. Let's perform the operations. So we have the first one, number 17, 7 times cosine pi over 3 plus I sine pi over 3. That's one complex number multiplied by another, 4 cosine pi over 4 plus I sine pi over 4. That's the other. So a rule, when we multiply, you multiply the r's and you add the angles. So multiply the modulus and add the angle. So this is pi over 3. Let's see, is that right? Yes. And of course you simplify this, so it will be cosine pi over 3 plus pi over 4 is 7 pi over 12 if you take the least common denominator. And we're going to leave it like this, unless it says otherwise. So we leave it in a trig form. So that's how we divide, that's how we multiply. Now we're going to divide. I have 3 cosine 2 pi over 3 plus I sine 2 pi over 3. And the other number is 6 cosine pi over 6 plus I sine pi over 6. The rule is that we divide the r's and we subtract the angles. Okay, now simplify 1/2. So cosine here would be 2 pi over 3 minus pi over 6, 4 pi over 6 minus pi over 6, 3 pi over 6, which is pi over 2, plus I sine pi over 2. And again, you leave it in trig form unless it says otherwise. If it says to write it in standard form, then we should do that. Number 19, it says write in standard form. So the number is 5 cosine pi over 12 plus I sine pi over 12. All that to a power 4. So here we don't have anything. Our numbers in a trig form. So that was the de Moivre theorem. So you take 5 to the power 4, and then taking a power means you multiply the angle pi over 12 then plus pi over 12, so 4 times. So that will be 4 times pi over 12 plus I sine 4 times pi over 12. So that's our rule. 5 to the 4th is 625. And here it's cosine of pi over, let's see, pi over 3. Is that right? So that's 12. Okay, yes, pi over 3 plus I sine pi over 3. We know this since it says right in standard form, cosine of 60 is 1/2 and sine of 60 is root 3 over 2. So it's 625 over 2 plus 625 root 3 over 2i. And that's it. It's in the standard form. All right, so if the number is not given in the trig form, if it's in standard form, 2 plus 3i, for example, to the 6th power, you need to write it in trig form. Write in trig form first, and then apply the de Moivre theorem. So you should get here the answer will be 2035 minus 828i. All right. Now, roots. Now we're going to find roots. Find the 4th roots of negative 16. Find all 4th roots of negative 16. So first we need to write our number z, which is negative 16 in a trig form. Negative 16 is on the real axis, so the angle is negative, so the angle is pi. So this is the trig form of our angle, of our number. So the 4th root of z, according to a formula, will be the 4th root of negative 16, and then cosine what do we do here? We take the angle and we add 2 pi k and divide by 4 plus I sine, take the angle, plus 2 pi k and divide by 4. K is 0, 1, 2, and 3. So if you take k equals 0, you'll get the first one. If k equals 0 and you substitute, you'll find the first one. If k equals 1, you'll get the next one. K equals 2 and k equals 3. So if k equals 0, you're going to have 4th root of negative 16. I can write this 4th root of, let's see, 16 is 2 to the 4th, right? So, okay, so the 16 here, actually it's positive. So, because r is 16. Okay, so if k is 0, you're just going to have cosine pi over 4 plus I sine pi over 4. And that is 2 and root 2 over 2 plus I root 2 over 2. And then you simplify root 2 plus I root 2. So this is the first one. The first 4th root. And then if k equals 1, you'll get the next one, 4th root of 2 to the 4, but it's going to be cosine of k is 1 now. Pi plus 2 pi will be 3 pi over 4 plus I sine 3 pi over 4. So that is 2 cosine of 3 pi over 4 is negative root 2 over 2 plus I root 2 over 2, which is negative root 2 plus I root 2. So that's the second one. K equals 2. You're going to have 4th root of 2 to the 4th. And here cosine of k equals 2. We're back. We're substituting here. Okay. So if k is 2, we have pi plus 4 pi. So that's 5 pi over 4 plus I sine 5 pi over 4, which is equal to 2. So cosine here is negative and sine is negative. So it's negative root 2 minus I root 2. And the last one, k equals 3. We're going to have the last root, k is 3. So 7 pi over 4 will be here. 7 pi over 4 plus I sine 7 pi over 4. So u in the 4th quadrant. So 2, cosine here is positive and sine is negative. So root 2 minus I root 2. We can see all those 4 roots situated symmetrically. So the first one was root 2 right here. Root 2 plus I root 2, that's the first one. And then the second one was negative root 2, it was over here. Negative root 2 plus I root 2. And then over here, that's both negative. And the last one's over here. Root 2 minus I root 2. As you can see, the angle between them is 90 degrees, right? Because there are 4 of them. And that concludes this review video.